This next learning target looks at a specific type of equation of a line, which is called slope-intercept form. There are three different equations for a line. Slope-intercept form is probably the easiest form to use, and every time you're looking at the same line, the slope-intercept form is unique. The other two forms can give you lots of different looking equations for the same line. So slope-intercept form has two parts. It's pretty self-explanatory. It's got the slope, which we represent with the variable m, and it's got the y-intercept, which we use the variable b for. Another way to think about this, when you're graphing from slope-intercept form, is start. The start value is your y-intercept, or your b value when you're looking at the equation, plus change, rate of change, or slope, or the m, times x. So the slope is what's being multiplied by the x. The start value is what's not being multiplied by the x. First thing we need to do is be able to analyze the equation in slope-intercept form. We need to be able to understand all of the different pieces of the equation so that we can use it to graph and interpret different word problems. So the first thing we're looking at is figuring out what's the slope and what's the y-intercept. Remember, it's start plus change times x. Rate of change, or slope, is what's being multiplied by the x. What's being added or subtracted is your y-intercept. Looking at example B, we have something being multiplied by the x, so we have a slope of 1/2, but we're not adding or subtracting anything. In this case, our y-intercept, or our b value, would be 0, because adding or subtracting 0 doesn't change the equation of the line. C is unique in the other way. We don't have anything times x, so our slope is 0, but we have a constant, or a value that's not being multiplied by the x, so that's our y-intercept. Next, we're going to do the same thing, but in the other direction. This time we're given the slope and the y-intercept, and we're going to put it into the equation of a line. So there's two ways to write the equation of the line. One is using y equals notation, and you've got your start plus change times x. Another is to use function notation. And some people like to put it in y equals mx plus b form. So I want to make sure that you understand you can use either y or f of x, and you can do start plus change times x, or you can do mx plus b for either notation. So to show you what I mean, I'm going to do those in opposite order for this one. So now we could use f of x notation for our start value plus change times x. I would simplify that to 5/7 minus 9x. So notice I used the function notation with the start plus change times x this time. Or you can do your y equals mx plus b form. All of those different ways of expressing your line or writing the equation of your line are acceptable. Now we're going to look at writing an equation from a graph. So there's two pieces of information that we need when we're writing an equation from a graph. We need the starting value, and the starting value is found on the y-axis. Remember, your y-axis is the vertical axis. So we're finding our start value on the y-axis. So in this line, our starting value is at -5. We also need our slope, or our rate of change, so we can count that as rise over run. Remember to make your triangle between the 2 points, and then you simply count. Our rise is 3, and our run is 6. So we have a slope of 3/6, which simplifies to 1/2. Once you've identified those values, substitute them into your equation. Again, you can use y equals mx plus b. or you could use function notation. The f of x just replaces the y. Nothing else needs to change. And finally, we're going to take a look at how to graph from slope-intercept form. Again, it's helpful to identify the slope and the y-intercept. So your slope is what you're multiplying by your x. In this case, we're multiplying our x by a negative. But for our slope, we need a rise and a run. So we need some numbers. Remember, if you're multiplying by 1, that doesn't change the value. So our slope is -1. Our starting value, what's not being multiplied by the x, is 3. So we go to the y-axis. We start at 3 on the y-axis. That's our y-intercept, where the graph crosses the y-axis. And our slope is -1. But in order to get a rise and a run, we need a fraction. If your slope is an integer, or a number with no fraction part, you can turn it into a fraction by putting it over 1. So now we have a rise of -1, which means we're going down. Our line should be falling when our slope is negative. A lot of students want to go down 1, left 1, but if you make a line between those 2 points, your line is rising. The reason for that is because a negative divided by a negative is positive. You don't have a positive slope, so you don't want to make both values negative. So here are your options. You can go down for the negative and then right for the positive one, or you can go up and left. Either one of those will give you the negative slope that you need. I like to use my slope over and over for the whole graph because a line goes on forever. And I want you to understand that that rate of change is between any 2 points on the line. That rate of change will be the same, or the slope. So once you have your points plotted, you can graph your line. To you try questions, please try these for our warm-up tomorrow so we're prepared for class.